All right. Slope. Do you guys remember slope from Algebra 1? So, slope is either thought of as rate of change. That's like the concept. You can think about it as rise over run, up, down, over, left, right, or the formula. You're going to need to memorize the formula for the quiz on Friday. y2 minus y1, x2 minus x1. You're going to have to remember slope formula, distance, and midpoint. I think are the three that I'm going to grade you on. So, this is kind of what slope looks like in general. If it's a positive slope, the line should be going up from left to right. So like going up a hill. If it's a negative slope, it's going down. Now these two people get confused. Zero slope is horizontal. Undefined slope is vertical. Think about like skiing. Can you ski on like a flat surface? Like something horizontal. I could just ski on the ground, right? So it has a slope. The slope is just zero because they don't move up or down at all. But undefined, can I ski down the side of a building without dying? No. So that's why it's undefined, because it doesn't really work. Okay, so you can make sure you know the formula and make sure you kind of know the generalization. So if I'm looking at A, find the slope between points A and B. Let's just use rise over run. So just count. You can always connect A to B. Now think about this. Each line on here is worth 2. So you can either like kind of draw a triangle. How many, let's think rise over run. How much from A to B, I'm going what? Down, how many? From A to B. Down, how many? But each one's worth 2. 8, but where's A at? Is A at a nice even point? Can you guys see it? A's like in between. So I'm actually going down 9, 2, 4, 6, 8, but then there's that 1. So I'm actually going down 9. Does that make sense? Yeah. How many over to get to B? Two, 4, 6, 8. Oh, but the scale on X is 1. 1, 2, 3, 4. So I'm going over 4. So negative 9/4 is my slope. Does it really matter where the negative is? Not really. If you put it up. Now just be careful. If I went to the left, that would be another negative. When you're counting, left is negative. Down and left are negative. Up and right are positive. So you can either count. If I look at B, from A to B, think about rise over run. How much up or down am I going? 0. How much left to right? When you have a fraction, 0 divided by 4 is just 0. That's why this is a 0 slope. Remember, slope's always m, because we're going to do y equals mx plus b tomorrow. Okay, you're not always going to have a graph, though. So on example 2, let's find the slope using the formula. y2 minus y1, x2 minus x1. So remember, label x1, y1, x2, y2. You don't have to label, but it comes in handy if you want. So the slope here is going to be y2 minus y1. 5 minus 1, x2 minus x1. 1 minus a negative 7. On your homework tonight, I should see that when you have 2 points. What's 5 minus 1? Now what happens to the negative negative? Turns into a positive, so it's 4/8. Your slope should always be reduced. So what is 4/8 reduced to? 1/2. And remember, we can reduce in the calculator if it's not like something easy. 4 divided by 8, and then you hit math frac. And that can reduce it. So then B, slope there would be 9 minus 3 over 4 minus 4. What's 9 minus 3? Nine minus 3. Thank you. 4 minus 4. Can you divide by 0? In math? No, so this is where you get the undefined. So make sure you know the difference between these two things. See how here 0's in the numerator? That's how you know you have a 0 slope. 0's in the denominator is undefined. And this shows up on the quiz, and every year I have students flip-flop it. Depends on where 0 is. Okay, let's look at the story problem. So 2 people go outside to exercise. Find the rate at which each person exercised in miles per minute. So person A, person B. So if you look at the graph, how far in miles per minute do you think person A is going? It's kind of hard to see. But person A, here's kind of what the scale should look like. So person A goes 4 miles in 20 minutes. So if I reduce that, she goes 4 miles in 20 minutes. What would that reduce to? One-fifth? So 1 mile for every 5 minutes. That person has a 5-minute mile. Person B goes 2 miles in 40 minutes. So what does that reduce to? 1/20th? So they walk 1 mile every 20 minutes. We always say like a 20-minute mile or a 5-minute mile. Nobody ever says a 20-minute mile because people don't really want to claim that. At least I would. But a 5-minute mile is good. We're just writing it the opposite way. What's the relationship between these rates and the slopes of the segments? The slope of line A would be 1/5. Every 1 mile you'd go up 5. The slope of line B would be 1/20th. So rate and slope are the same thing. So if it asks you for the rate at which they're going, it's really asking you for the slope. What does the slope or the steepness of the segment tell you about each person? So if we look at the steepness of person A versus the steepness of person B, what does that tell me in terms of how fast they're going? If you didn't see this, who's going faster if you just saw the graph? Yeah, right? Person A is running faster since the slope is steeper. Right, so the faster you're running, the steeper your slope. Person B is walking much more slowly. Okay, the last thing we got to talk about slope, again, review, is parallel slopes, perpendicular slopes. I saw this question on the SAT. It was like, find the equation of the line parallel to this one. So if two lines are parallel, their slopes are what? What do you think? The same. Or you can put equal. So two lines are parallel if they have equal slopes. Perpendicular slopes, do you guys remember what they are? Reciprocal and there's one other thing. Opposite. They have to be opposite reciprocals. So if one of the slopes is 2/3, the perpendicular slope would be what? What's the opposite reciprocal of 2/3? -3/2. If the original slope was 1/2, the perpendicular slope would be what? You could just write -2 or -2/1. Now, there's not a whole lot of room to write for these next three problems. I apologize for that. Let's go through and find the slope of all 6 lines. And we got to say whether they're parallel, perpendicular, or neither. Neither would be like if they were just opposites. Like if one was 2 and the other one was -2. Or if they're just reciprocals, like 2/3, 3/2. Or if they really don't make any sense at all. So, let's do A together. So you got to find the slope of both lines. So you can always do slope M, and then I just put like a subscript for 1. So this is where knowing the equation comes in handy. So 4 minus 0, 7 minus 1. So 4, 6. What's 4, 6 reduced to? You need to reduce your slopes. Otherwise, you won't be able to match them. Slope for line 2, 9 minus 0, 3 minus 9. So 9 over -6. Like I said, if you get confused, go to your calculator, hit math, frac. -2/3. No, I mean -3/2, sorry. So these would be perpendicular. I probably shouldn't use that example anymore. Now when I see your homework tomorrow, I should see both slopes and then an answer. Don't just give me the answer. So for B, line 1 would be -2 minus 1, -7 minus the -3. be careful with your negatives, positives and negatives, okay? That's where a lot of people screw up, is they just do the math wrong. If you need to, use your calculator. -2 minus 1. The -7 minus the -3 becomes a plus. So you get -4. When you have a negative over a negative, what is the fraction term? So 3/4. Slope for line 2, 4 minus a -1, 8 minus 2. That becomes a plus. 3/4 and 5/6 aren't the same. They're not opposite reciprocals. So this is where that neither comes into play. And then the last one, 5 minus 4, 10 minus 7. One-third. And line 2, 5 minus 3, 8 minus 2. Two, 6. What does 2, 6 reduce to? Again, 1/3. So these are what? Okay, so I should see always both slopes, then give me your answer. Questions?